Alright, so welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, my name is Dr. Umashankar and I am your physics educator. So, in this session, guys, we are going to continue with our relative velocity in two dimension. Okay, so lastly, we have started the relative velocity in two dimension and we have dealt with the famous Rain Man problem, umbrella problem. Okay, okay. So guys, in this session, we are going to deal with the other famous problem, that is, you can call it a, see, anything. So normally it is named as river swimmer problem, okay, or river boat problem, okay, or aeroplane wind problem, aeroplane wind problem. Oh my God. Harsh, very good afternoon. Jai Shri Krishna, कैसे हैं भाई आप? Just give me a moment. Huh? There is something missing. Just a moment. Huh? Just a moment. Yeah, sorry. I think better now. So Harsh, how are you doing? Beta? Welcome to the channel. My name is Dr. Umashankar and I am your physics educator. So guys, in this session, we are talking about Harsh. We are talking about the relative velocity in two dimensions. So are you aware of relative velocity method, Harsh? क्या आप रिलेटिव वेलोसिटी मेथड से अवेयर हैं बेटा? हमने इससे पहले इस चैनल पे रिलेटिव वेलोसिटी वन डायमेंशन में किया हुआ है. We have completed relative velocity in one dimension on this channel previously, and relative velocity in two dimension. This is the second session. In the first session, we have seen the famous uh, 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 Rain Man problem. Okay, and umbrella man problem, rain man problem, whatever you say. Now in this session we are dealing with the river swimmer, river boat or aeroplane wind problem. So Harsh, can you see me? You are saying, sir, why you are ignoring me? Arey, I am not ignoring you, bhai. Why I would ignore you, beta? है ना? So please tell me, do you have any information? Hello Shisai, how you doing, beta? You are not coming to the live sessions recently. All good? आप लाइव सेशंस में नहीं आ रहे थे? हाँ, ऑल वेल? No, nothing to be sorry about, beta. So let's continue. So lastly, we have seen the rain man problem, umbrella woman problem. Now, in the same way, relative velocity in 2D, I'll be completing it today. So there will be only one topic left of kinematic, that is the circular motion. Okay. So maybe tomorrow we'll be completing that also. So now please see. Acha, afterwards, I have decided to start 11 part 2. अच्छा एग्जाम आ रहे हैं कोई बात नहीं. So इसके बाद ना, as we have discussed Shisai, so I'll be beginning with the two topics. I'll be starting with the 11th class physics, all 11th class part 2, है ना, properties of solid, fluid and thermal. Okay, these three topics I'll be completing. Okay, I'll see how I can complete it. If I can do one short sessions, or I may do, yeah. And along with, we'll start with the Newton's law. So two topics will run together. Okay, this way, I think we can, little bit hurry up the syllabus. Okay. So now river simmer, river boat, aeroplane, wind problem. So all these are the same thing. Okay, the concept are the same. This is something of the relative velocity in 2D. No, no, it's my duty bit only. Okay, nothing to be thankful about. Ah, let's do it. But maybe we'll have to change the timing a little for next, 8-9 days, because I'm from tomorrow. I'll be going to Calicut for some offline teaching. Okay, so we have to a bit change the timings and all. That I'll see to what we can do. Okay. Now please understand this. So see, let's suppose this is the river. We all have seen river, right? Now a river, let's suppose the river is flowing at some velocity. Let's call it VR. Okay. So see what we are going to do. We are going to see this concept with the help of questions. Okay. So now let's suppose VR, that is the relative velocity of the river. Let's suppose it is 3 kilometer per hour. So a river is flowing at some velocity in this direction. Now there is a swimmer, and this is the same thing can happen with the boat, aeroplane, wind. So wind is also a fluid. It flows like some river or something. So flow of the wind is there. Aeroplane is flying in the river. Okay, all that are the same thing. Okay, so I can consider swimmer. Right. There can be question in which they may say it as a boat, or there may be a question in which they, instead of river, they say that this is the wind. Okay, this is the wind, and this is your aeroplane. So anything can be done. Okay, but the concept remain the same. Now please understand this. I want to ask you something. Now please tell me. Let's suppose we are having a swimmer, and swimmer is trying to cross this river, that is 16 kilometer. Let's suppose this width of the river is 16 kilometer. Now this swimmer has started from this point, and he is moving like this. He is moving like this, and this is the velocity of swimmer as seen in the river. Velocity of swimmer with respect to the river. So whenever it says like this thing, the swimmer is swimming in a still water. So that is nothing but the velocity of swimmer with respect to river, not with respect to the ground. Okay, are you getting my point? Okay, so velocity of swimmer with respect to river. Let's suppose that the swimmer is trying to move at a velocity of 4 kilometer per hour. Okay, 4 kilometer per hour. Now you tell me, will this swimmer is going to reach this point on the river? Let's suppose this is A. Will he be able to reach this point? What do you think? See, this is very, very simple, very, very practical. Right? Is he going to reach this point? That is the vertically opposite point here. Is he going to reach there? You tell me. Is he going to reach there? No, sir, absolutely not. Why, sir? Because see, when you practically also, let's suppose your friend, I don't know swimming. If you are knowing the swimming, see, and but I have seen many people swimming because I live in the city of Haridwar, na? Roorkee, Haridwar. So very, Ganga River is flowing in our city. So I have seen people swimming in this. So when we see them swimming, so they swim like they think that they are swimming in a straight line. But if you observe from the ground, you will see that they are swimming in some inclination, right? Do you agree to it? Okay, so now please think of it. Just practical, then we'll apply the formula. There is no formula actually. So when he's trying to swim like this, or she's trying to swim like this, basically due to the velocity of the river, this swimmer will move somewhat like this rather than going this way. If someone is observing from the ground, let's suppose we are standing on the ground and observing this swimmer, right? Now, from the ground, when we are observing this swimmer, do you feel that he inside the river he is trying to move in a straight path or the perpendicular to the velocity of the river, but from the ground when you observe it, it is moving somewhat like this. Do you feel so? Right? Okay, so this is the concept of this river swimmer problem. See, let's now start doing it. See, very simple. We know the concept of relative velocity, we know the concept of vector, and that is only the things required. So see, this is the velocity of swimmer with respect to river. This is given to be 4 kilometer per hour. Okay, this is the velocity of river, that is 3 kilometer per hour. So this is the velocity of river with respect to ground, obviously, and this width is 16 kilometer. Okay, this width is 16 kilometer. Now let's try to understand it. So now when I say velocity of swimmer with respect to river, so it is also velocity of swimmer minus velocity of river, and when we write like this, basically it is with respect to the ground. Similarly, that we have seen the rain man problem. Na? Velocity of rain with respect to man, okay, velocity of r with respect to ground minus velocity of man with respect to ground. Now same way, when we write velocity of swimmer with respect to river, it is velocity of swimmer with respect to ground minus velocity of river with respect to ground. Understood? Now from here, can we say the velocity of swimmer with respect to ground is velocity of swimmer with respect to river plus velocity of river with respect to ground. So see, this is not the formula but the concept. So in each or every question now you have to do this. That is there in this case. Otherwise, there is nothing in this. Every question you have to do this. Okay, like in this case, see. Now, what is the velocity of swimmer with respect to river? So velocity of swimmer with respect to ground. So what is the velocity of swimmer with respect to river? It is 4 of j cap, right, in the form of vector, isn't it? Yes or no? Please answer me. So we want to write it in the form of vector, right? Okay. So velocity of swimmer with respect to river is 4 kilometer in j cap direction, that is in positive y direction. Now, what is the velocity of river with respect to ground? The velocity of river with respect to ground is 3 I cap. This is in positive direction. This is in positive direction. Understood? Yes or no? Okay, so this is velocity of swimmer with respect to the ground in this case. Now, what can they ask you? So they can ask you, let's suppose, so once you get the velocity of swimmer with respect to ground, the question is over only. Now they may ask you what is the time to cross the river. Time to cross river. Okay, so what is going to be the time to cross the river? So see, what is the distance he has to move? So he has to move 16 kilometer. Okay, which direction distance is this? So this is in the y direction. Okay, this is in the y direction. Upon what is the velocity in y direction, that is going to be the time, isn't it? Right, because acceleration is constant. Do you agree or not? Please answer me. Right. So what if acceleration is also given? So if constant acceleration is given, you can use the equation of motion, isn't it? Yes or no? Please answer me, guys. Right? Okay, so what is that distance? This is 16 kilometer. What is the velocity in y direction? The velocity in y direction is 4. So it is going to be equal to 4 hour. Taking care of the unit. Sy is 16 kilometer. This is 16 by 4 kilometer per hour. So this is going to be 4 hour. Now what else they can ask you? They can ask you at what point at what point on opposite bank, on what point on opposite bank he arrives. At what point on opposite bank he arrives. Now tell me. You do this. This is also known as the drift. Okay. What is the significance of drift? So see, it is the only significance is this, that if the swimmer is trying to swim perpendicular to the direction of the flow of the river, he thinks he is going to reach this end of the shore, but he is never going to reach this end of the shore, right? He'll reach somewhere here, Obviously, because see, he is moving in this direction, but the river is pushing him in this direction. And remember, the same concept is going to happen if there is a boat instead of a swimmer, or there is an aeroplane in the wind, anything. Okay, anything. So what is the drift? So basically now, this is the that is why it is in two dimension. So see, from here to here, let's suppose this B and this C. Okay, so obviously since the horizontal velocity in this direction, see, you see the horizontal component 3 I cap, this is 4 J cap. So this is responsible to the motion in Y direction. This is responsible for motion in Y direction, obviously, and this is responsible for motion in X direction. So, like, what is the drift? Drift is basically the distance he covers or she covers in horizontal direction. Okay. So in horizontal direction, how much distance he is going to cover, sir? So he is going to cover, let's suppose this drift is X or BC, you can say. So what is going to be this BC? Okay, so BC is going to be, what is the speed in X direction? Okay, speed in X direction and time. Okay, so what is the speed in X direction? This is 3 and time is 4. So this is going to be 12 kilometer, isn't it? Okay, yes or no? Please answer me. Hmm? Right. Okay, understood. So this is the drift. So even if he wants to reach the opposite end of the show, but he's never going to do that. He'll have some drift, and due to that drift, he is going to reach to some point ahead of that point, and that is in this case 12 kilometer. Right. Now see, please use your common sense to solve this. See, in school what they do, they start with this minimum distance, minimum time, and then students start learning that using. But if you are good at concept, there's no need of all those things. That will be, you can consider it as a question. This is the only concept, right? This is the only concept. And now, if this direction, if the second component 3 I cap, if it would be minus 3 I cap due to some reason, what reason, sir? If he is trying to swim this way, okay, at some inclination, yeah, it is very easy. So it is going to move in this direction at some inclination if, then it will have a component in negative X direction, then it will be minus direction. So drift will be in the other side. Okay, so whatever you have learned till now, there is not an iota of concept that is you are gaining here, right? Just because these problems are frequently asked and given in the questions. So that is why we are dealing with it. Otherwise, there is no need actually. Okay, now what else they can be asked? So this is drift. At what point he arrives? So this is drift. That is going to be 12 kilometer. Okay, what else they can ask you? What is the actual distance he swims? What is the actual distance he swims? Okay. Now let's try to do that. What is the actual distance he swims? Can you please tell me? Okay. So now what is the actual distance he swims? Okay. So obviously, so the actual distance, so there can be any way that you can find. Like for example, so he traveled 16 kilometer this way, then he traveled 12 kilometer this way. Not then, but along with. But you can separate it in the vector thing. We know all of us knows the vector thing. I'll just draw it here. So this is 16 kilometer. Okay, this is 16 kilometer. This is going to be 12 kilometer. Okay, so if this is 16, this is 12. What is it going to be? So 16 square plus 12 square, that means 20 kilometer, isn't it? Okay. Yeah, please ask me. She said, yeah. And the other way could be you can first find the velocity. So we have this 4 and 3. So what is the magnitude of the velocity? It is going to be 5. Okay, so when the velocity magnitude is 5 kilometer per hour, the actual distance is speed into time. So it is going to be 5 into 4, that is 20. Okay, so any way you want. I'll just explain. I'll just explain. Okay, I'll just explain. So you are saying, sir, can you please repeat velocity of swimmer with respect to the river and velocity of swimmer with respect to the ground? Okay. Now please understand this. Now there is a river which is flowing at some velocity. Let's suppose at a velocity of 3 kilometer per hour. Okay. Let's suppose it is having a velocity of 3 kilometer per hour. Now someone is swimming in the river. Someone is swimming in the river. So he is having the velocity with respect to the river. Because when he is inside the river, his motion is with respect to the river, isn't it? Yeah. Like for example, in this question, I said he is swimming at a velocity of 4 kilometer per hour. See, this is not a confusion. This is basically in books also they try to confuse you with this, isn't it? They tell you that the velocity of swimmer in still water, isn't it, is 4 kilometer per hour. So now students think that this must be velocity of swimmer with respect to ground. No, no, no. It is not velocity of swimmer with respect to ground. It is basically velocity of swimmer with respect to the river. Are you getting my point? So whenever they say that someone is swimming in the water with this velocity, that is the velocity of river swimmer with respect to the river only. Right? Okay. Similar. See, it is very similar way. Like we are like suppose so it is said a car is moving at a velocity of 20 kilometer per hour on road. That means yeah, yeah, it's still water. This is this that is I come to understand that. Na? She said this is I don't know why they create this confusion. Okay, but there is nothing. See, it is very simple logic. When we say that we are walking on the ground, okay, let's say we are walking on some ground. Now, when we are walking on some on a road, a car is when we say a bus is moving in a straight line. So when bus is moving in a straight line, by default you consider it with respect to the ground, isn't it? Though the ground is still, considering the ground is still, right? Isn't it? Now, in the same way, if something is swimming or something is moving inside a river, so obviously by default, when you are seeing some velocity with respect to something, okay, so river is also still, so that is the velocity with respect to river only. Did you get it? No, you didn't get it. Let's suppose, so lastly we have done the police thief problem, remember? Right? Police thief problem, right? Now, when we write velocity of police with respect to thief, what I said to you, that whenever we are observing something with respect to some observer, so observer kept on a stop, you stop it, isn't it? So whenever you are seeing the velocity of something with respect to the other thing, you are always stopping it, isn't it? So that is unnecessary to say even that when the river is still water, isn't it? Now just leave this. I say velocity of police with respect to thief. So velocity of police with respect to thief, it means velocity of or speed velocity of police when when thief velocity is 0. Do you agree or to it or not? Please answer me. By default, this is the meaning of the relative velocity. When you are seeing the velocity of something with respect to the other thing, the observer always stops. Then only it is the relative velocity. Are you getting my point, beta? Please answer me. Agreed or not? Right? Now, when they say that velocity of a person is swimming in still water, still means that the river is stopped. Okay, so it is the relative velocity. Understood? Okay. Let's do one more question then. If you are okay to good to go, right? Okay, so let's take one more question. So we have a river again. Okay, we have a river again. Now let's suppose we have a swimmer here at point A and the river is flowing at a velocity of 8 km per hour and this swimmer has a velocity in this direction that is 10 km per hour. That is 10 km per hour and this is going to be 30 kilometer. This is going to be 30 kilometer. Now find everything, right? The time taken to cross the river, okay? Time taken to cross the river, to cross the river, right? Okay. Second, the drift, that is at what point he arrives on the other shore. And third thing is actual distance he swims. See, they can make you any number of questions in this, right? Please go for it. I'm very sure we'll be able to do it. Yeah, angle I have to give right. Sorry. So from the velocity, it is making, let's say, 37 degrees. Now please do it. Yeah, very good. Why you are thinking that you are wrong, beta? See, don't be in any doubt. Okay, you have done it correctly only. When you have applied the all the concepts correctly, why you are thinking that you are having a doubt? Okay, please don't doubt yourself. When you are applying the concept in a right way, that is only the concept when applied is right. Whatever is happening, let it happen. See, please understand this. So he is moving at the 37 degree. Now see, let's do it quickly. So this is what? This is velocity of swimmer with respect to river. Now velocity of swimmer with respect to river is also velocity of swimmer with respect to ground minus velocity of river with respect to the ground, right? Now from here, velocity of swimmer with respect to ground is going to be velocity of swimmer with respect to the river plus, okay, velocity of river with respect to the ground. Now definitely it is going to have two components. So this is how much? This is 37 degree, right? This is 37 degree. Now when this is 37 degree beta, so this is going to have two components. Okay, one in this direction, two components, one is going to be in this direction, one is going to be in this direction. Now this is 10, so this is going to be 10 cos 37, right? And this is going to be 10 sine 37. Now this 37 degree thing we remember now. So if this is 37, this is 3, this is 4, this is 5. So this is going to be 4 by 5. So this is going to be 8. Now this is minus 8 of I cap, isn't it? Because it is in negative x direction. So 8, how come? So cos 37, I have put 4 by 5. So 2 and this will go like this. Now this is going to be 3 by 5. 3 by 5, that is 6. So this is plus 6 j cap, and velocity of river is plus 8 I cap, isn't it? So it becomes 6 j cap, right? 6 j cap. Now see how beautiful it is. See, the swimmer is thinking that he is moving in this way, but if you observe from the ground, he is moving in a straight path, just perpendicular. So it doesn't have any velocity in x direction. It has no velocity in x direction. So when he has no velocity in x direction, his drift is obviously going to be 0. Now drift is 0. So what is the actual distance he swims? He swims 30 kilometers, isn't it? Because it has no drift. It has no drift. So he basically moved in this path straight, isn't it? Isn't it? Yes or no? And what is the time taken? So the time taken is going to be, what is going to be the time taken? So the time taken is going to be, so what is the distance he traveled in y direction? That is 30. In y direction, what is the velocity? 6 km per hour. So this is going to be 5 hours. Isn't it? Very, very easy. Yeah? Yes or no? Please answer me. And try to think it practically also. Like he want to move, he want to, he want to reach the other side of the shore. He want to reach the other side of the shore. He want to reach basically the other side of the shore, just opposite, isn't it? In just opposite. Okay. So when he want to reach there, okay, he want to reach there like that. So basically, he must be swimming in this direction, right? Because the river is pushing him in this direction, right? I hope this is fine to you. Okay, let's solve one question then. Just a moment. Okay, let's try this one then. Very, very simple. Oh my god, you can't see the whole question. Just one minute. I think this is fine now. Let's do this. Please go for it. Let's try doing it. I'm very sure we can do. No problem at all, beta. Please go for it. Time is, yeah, good. Okay, happy Bhai Dooj and happy Diwali. But I think Bhai Dooj is tomorrow, no? Am I wrong? Is Bhai Dooj today? Oh, why? My sisters are going to kill me then. भाई दूज आई गेस इज टुमारो ना, कल है ना भाई, भाई दूज आज है। अरे सीरियसली बताओ भैया, 15 लिखा है गूगल पे, 15 को है। She said it is a festival after Diwali. It is just like Raksha Bandhan. Have you heard of Raksha Bandhan? I guess yes. Right. So in this Bhai Dooj, like after Diwali, 2 days, 3 days after Diwali, normally it happens to be. So अच्छा यमुना नगर में नहीं नहीं, यहाँ पे हम कल मना रहे हैं 15 को, है ना? आप यमुना नगर में रहते हो? बहुत करीब रहते हो यार मेरे, 1 घंटे में आ जाऊंगा तुम्हारे घर। So she said Bhai Dooj is a festival, as I was saying, just like Raksha Bandhan. In this, like sisters, like in Raksha Bandhan, they used to tie the Rakhi. So in the same way, Bhai Dooj is there. But in this, they don't tie anything, just some, tika type. Uh, Chalo. आओ। So a man can swim. एक आपको कुछ आइडिया है? What is this 2/3 root 3? What have you answered? This is wrong. Drift are you answering? No, 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 no. Wrong answer, she said. So, Iki, we are doing this, relative velocity in 2 dimensions. So, lastly, we have seen the rain man problems. Okay, in which direction umbrella shall be opened. Right. So, in this, we are doing the famous swimmer river, boat river, or aeroplane wind problems. uh, Thanks. Yeah, it is 1/6 root 3. Now it is correct, Shifai. Okay, do you have any understanding of this relative velocity in 2D? अभी तो मैं आई एम इन लखनऊ राइट नाउ, मेरा होम टाउन वैसे लखनऊ है बट आई लिव इन रुड़की, इंडियन इंस्टीट्यूट ऑफ टेक्नोलॉजी रुड़की, आईआईटी रुड़की में। आओ कभी घुमाएंगे तुमको आईआईटी रुड़की, हॉस्टल का खाना खिलाएंगे, ठीक है? चलो खैर, एनीवेज, आई हैव टेकन मेनी क्लासेस इन अम्बाला, जगाधरी। जगाधरी स्टेशन है ना तुम्हारा? Anyways, so she say actually some of the research work, like I have completed my PhD. It's not like that you can live forever in IIT. So since I am pass out, but I am also like using the research facility. Some of the part of the work was left because it was a project by the government. Okay, in which I have done. Free is never free. First of all, it is never free. You have to pay, but that is very nominal charges, right? Especially for PhD. My fees of PhD was 7,000 rupees for 6 months, right? Excluding the accommodation part. Okay. So basically, I am doing some research activity in the lab. So that is why I am allowed to live there. And I think by the end of the March, I'll be going outside. So I have seen places outside of IIT Roorkee. So I'll live there. Okay. I have no mood of leaving Roorkee. Right. Okay. And I think I have never told you guys this. I am also associated with a engineering college in the capacity of head of department and dean research and development. So anyway, so a man can swim at a speed of 3 kilometer per hour in still water. So this is going to be like this. Okay, 3 kilometer per hour in still water. So 3 kilometer per hour in still water. Okay, he wants to cross 500 meter wide So this is 500-meter wide river flowing at 2 km per hour. He keep himself always at an angle of 120 degree with the river flow while swimming. So with the river flow, so river is flowing in this direction, let's suppose. So river is flowing. Please do tell me, Aki. Okay, do tell me if I am available there. I'll definitely meet you and show you IIT. Wonderful. You must always see. I tell you one thing, like one suggestion. Acha, you are going to the Himachal area. So for Himachal, why are you coming this way? From Saharanpur you can go. There's no need of coming to Roorkee if you want to go to Himachal. Anyways, so see what I was saying. So this is my suggestion to you guys. Like if there is any premier institute near you, okay, like any NIT, National Institute of Technology, any government medical college, not state government mostly, or any IIT near you. So always do visit there once or twice, right? Okay, so it is a wonderful experience. Okay, you will feel motivated by seeing the students, their life there. Okay, so let me come to the point. Today I have been talking a lot now, right? Okay, because only when we study, then only we'll be able to reach there. So yeah, not only for motivation, just for like you want to. That is, acha acha. Okay. Actually, what my view is on this, na, so when you go there, you will get a very positive vibe because like the confidence of the students, right? You will see like when you see a face of an IITian, na, he's full of confidence. Are you getting my point? Okay, like it's a different thing. Like I say very proudly when I say that I am taken PhD from IIT Roorkee, so there is like a sense of pride. Okay, so you can feel that aura inside the campus. Acha, I'm not aware of it. Okay. Anyways, let me come back to the question. We are talking a lot today. Normally, we don't talk this much. A man can swim at a. So let's get back to the point. Na? Otherwise, the recording, when someone sees the recording, he will say that sir is only talking, not teaching. A man can swim at a speed of 3 km per hour in the still water. He wants to cross a 500-meter wide river flowing at 2 km per hour. He keeps himself always at an angle of 120 degree with the river flow while swimming. Find the time taken. So this is 120 in this direction. Now you can take, so if this is 120, so I can take it off vertical axis. I can take angle anywhere I want. So this is going to be 60. You can take this 30 also, whatever you. Yeah, definitely. Like, if I am available at Roorkee, you are most welcome, right? But like sometimes now for teaching, I have to go to places. Like I have been since a senior faculty now I am. So like people are calling me from other states also to give some expert lectures. Sometimes on engineering, sometimes on physics, sometimes on any research thing. So now I have been going to Calicut tomorrow, Kerala. So there is 10 days lecture I have to give, right? So like likewise, okay. So if you come in Roorkee, I promise you, that if I am there in Roorkee, I will definitely meet you. Okay, you can write my name on Google and search for me. You can message me, okay, on like any platform where you find me, right? So let's get back to the point. So 120 degree. So this is 60 degrees. So see, now this is the velocity of swimmer with respect to river. See, whenever it is written 3 km per hour in still water, it is always the velocity of swimmer with respect to the river. So velocity of swimmer with respect to river. So again, velocity of swimmer with respect to the ground. So I'll directly write it. Velocity of river with respect to the ground, isn't it? I'll first write here, then I'll write again, right? So this is going to be velocity of swimmer river with respect to ground plus velocity of swimmer with respect to the river. So I can write velocity of swimmer with respect to the ground. So velocity of river with respect to the ground. So this is 2 of I cap. Then velocity of swimmer with respect to the river. So this is going to be C. Now let's see the components. Okay. So the horizontal component is minus of 3 cos 60. So cos 60 is 1 by 2. So can I write directly minus of 1.5 of I cap? Isn't it? Isn't it? So plus, see, I'm writing the velocity of swimmer with respect to river in Cartesian. So we have this 3 kilometer per hour now taking its component in x direction. So it is in negative x direction. So I'll write minus 3 cos 60. So 3 cos 60 is 1 by 2. So 3 by 2, that is minus 1.5 of I cap. Right? Then in the vertical direction plus 3 sine 60. 3 sine 60. So sine 60 is 3 by 2, that is 1.5 of root 3 of j cap. Isn't it? Do you agree or not? Please answer me. Is it fine? Yeah? Are you getting this? Na? Now this is going to be how much? So velocity of swimmer with respect to the ground, it is going to be 0.5 of I cap and plus 1.5 root over 3 j cap. Root over 3 j cap. Now what is going to be the time he takes to cross the river? So see simple. When you are calculating in two dimension, break always in x and y. In projectile motion, what we did? We break in x and y, isn't it? We break in x and y. Have I done anything wrong? No, I have done everything correctly, na? She said. Yeah, okay. So every time whenever you are seeing motion in two dimension, motion in a plane, always break the motion in x and y. That is why we have learned the vector. So now what is the time? So he need to move 500 meter, that is 0.5 kilometer in this direction. So this is going to be 1.5 of root 3 and this is going to be, the unit is going to be in hour. So this is going to be 1 by 3 root 3 hour, isn't it? Okay. So this is the first part, 1 by 3 root 3. Agreed? No worries, sir. Now what is going to be the drift? The second part, at what point on the opposite bank will he arrive? So in the second part, they are asking you about the drift. Okay, so what is the drift? Basically, so see, now if so see, they can make any language. They can ask you that from point A, is it going in right or left? So in this C, the it has some horizontal velocity, and that horizontal velocity is in positive x direction. So basically, the drift will be in positive x. Okay. So what is going to be the drift? So it is going to be velocity in x direction into the time. So time is how much? That is how much we have calculated. 1 by 3 root 3. So this is going to be 1 by 6 root 3 hour, right? Sorry, kilometer. Now they may ask you this, that what is the actual distance he traveled. So that also you can do, right? You can take the magnitude. You can get the magnitude of this thing, 0.5 square plus 1.5 root 3 square. Once you have the magnitude of the velocity, or when you get the speed, you can multiply it with time, and that is will be the actual distance he traveled. Okay, then easy peasy, isn't it? Yes or no? Now let's try one more. Sure. Let's do this one. AK, did you get this? क्या नाम है आपका? AK, what is your name? If you don't mind telling me. And all the other students, welcome to the session. My name is Dr. Umashankar and we are dealing with the relative velocity in 2D. Basically, we are dealing with the famous river boat problems. Ansh. Okay, wonderful. चलिए करिए. Let's do it. क्या बताओ एंगल 180 माइनस cos 2/3. अच्छा. What about you, Ansh? She said, I'll just see to it. Ansh, what is your answer to this? Hmm. Time doesn't seem correct. Also, the angle is also not seems to be correct. Okay, you are telling me the angle with respect to the direction of the river flow. Okay, let's give some time to Ansh also. Ansh, do you want to answer this question? Are you trying? All the other live students, welcome to the session, my dear. You can also try answering the question. Yeah, I think some conceptual mistake you are doing. Just try to use like little bit of concept. Let's do it again. Please do. See, these questions are quite frequently asked. And you are not able to do it. Okay, I'll do it. She say, have you attempted? Your attempt is completed. Hmm. It doesn't seem right again. Please try to understand it. Basically, this is the standard minimum distance case. Okay. This is also the case of minimum distance. Okay, I'll just explain that to you also. So there is a river. It is flowing like this. Now, in this case, a man can swim in still water at a speed of 3 km per hour. He wants to cross a river that flows at 2 km per hour and reach the point directly opposite to his starting point. Now, see, the river, let's suppose, is flowing in this direction at a velocity of 2 km per hour. Right? Fine. right, sir? Now a man is swimming and he wants to cross the river that flows and reach the point directly opposite to his starting point. So he want to go to this point. Okay, he want to go to this point. Now please tell me, yeah, yeah, that's correct only. Now please understand this. Now please understand this. So we are moving from A to B. We are moving from A to B. So from A to B now, if we want to reach to A to B, one must swim in this direction with respect to the river. Then only with the help of the velocity of the river, he is going to reach to this point. First of all, tell me, is this clear? Please answer me. Ansh, you also please tell me. Is it fine to you? Velocity of swimmer with respect to river. So basically, he has to flow in this direction. Okay, he has to flow in this direction, isn't it? Right, sir. So again, you can consider the theta from anywhere or any way. In which direction? That is, find the angle his body makes with the river flow. Okay, so with the river flow, basically, this is this direction. So this is you have to ask. So let's suppose this is theta. Let's call it theta. Now please understand this. Now he want to reach here. So when we are talking, now please listen to me carefully. So when in this case, when he has to reach directly opposite, do you agree that this must not have any component in x direction? Because see, when has to reach in this point, that means drift has to be zero. What is the meaning of it? That drift has to be zero. Drift means its horizontal motion has to be zero. So when its horizontal motion is to be zero, when his horizontal motion is to be zero, the velocity of the swimmer with respect to ground in I direction, that is in positive x direction, must be zero, or negative x direction, whatever it is. In I cap, it must be zero, isn't it? Do you agree or not? And it must have in some j cap. Okay, so what is the velocity? So let's take the component. So now this is going to be, so velocity of swimmer with respect to ground. So we know it is velocity of swimmer with respect to river plus velocity of river with respect to the ground. So velocity of swimmer with respect to river, what it is going to be? So it is going to be minus of velocity of swimmer with respect to river. Okay, and that is going to be in the direction, so cos theta. Okay, plus, so this is I cap. This is basically I cap, or I'll just do like this. So this is going too long now this way. Just leave it. So you understood that it must be having zero in I direction. Then only it has zero drift. Now what is the I direction thing? So what is the component of velocity of this river? So we have learned the vector now, so we can use those concepts. So this is going to be velocity of river into cos theta, and this is velocity of river in this direction. Both combined must be zero. So both combined must be zero. So velocity of swimmer with respect to river into cos theta into, oh, I have taken theta from here now. So I must do sine theta now, because I have taken theta from this. Okay. So yeah, yeah. Very good. So this is sine theta and this is going to be VR. So can I write, since this is 0, so it means that velocity of swimmer with respect to ground sine theta, that is the horizontal component, is this direction. Okay, so I have taken this direction as positive, so this direction is going to be taken as negative, is equal to 0. So basically what you have to do, this is velocity of river with respect to ground. So what you have to do, velocity of swimmer with respect to river, sine theta is equal to velocity of river with respect to ground. So sine theta, we can take any way you want. Na? I have taken from here. You may have taken from this side. Okay, you may have taken from here also, alpha. In that case, it will become cos alpha. So depending upon the reference. But I am trying to make one formula also as given in your books, right? So VRG upon VSR. Now, if you have ever trying to read from the books, this is given to you, na, right? condition for minimum distance, isn't it? Minimum distance condition. So in the questions, it is also given na, like questions like this, minimum distance. So if the swimmer has to cover the minimum distance, right? If the swimmer has to cover the minimum distance, this is going to be the sine theta, isn't it? Do you agree or not? Please answer me. Velocity of river with respect. Have you seen this formula first of all? Tell me yes or no. Right? So for the swimmer to swim the minimum distance, this condition should be satisfied that the sine theta is velocity of river with respect to ground upon velocity of swimmer with respect to the river. Understood? Isn't it? अंश डिड यू गेट इट? समझ में आया बेटा? ठीक है, देखिए कुछ नहीं किया. सी, ड्रिफ्ट जीरो होना चाहिए फॉर द स्विमर टू रीच जस्ट अपोजिट साइड. Okay, for swimmer to reach just opposite side, the drift must be zero. So drift is due to, why there is a drift? Because there is some velocity in x direction. So if there is no drift, there is no velocity in x direction. So we are just closing by the velocity in x direction. So velocity in x direction is zero. So what are the velocities in x direction? So there is one component of this in x direction, and the river velocity is already in this direction, isn't it? So they both must be equal. Ansh, did you get it? So from here we get the condition of minimum distance. So from here we can get this theta. So sine theta is going to become, so see, what is the velocity of river with respect to ground? Velocity of river with respect to ground, that is 2. Velocity of swimmer with respect to river, that is 3. So sine theta is 2 by 3. Yeah. Yeah, it seems correct now, right? So sine theta is 2 by 3. Understood, beta? Please answer me. Right? Do you agree? Do you agree? Yes or no? Please answer me. Okay? Understood? Since drift is 0. Yes or no? Please answer me. Ansh, did you get this? Sine theta is equal to 2 by 3. Please answer me, na beta. यस सर, परफेक्ट. अरे समझ में आया नहीं भाई क्या? बाकी लोग, other live students, you may please tell me if it is correct or not. So sine theta is going to be 2 by 3. Now what else they are asking you? They are asking you how much time will he take to cross the river 500 meter wide. So this is 500 meter wide, that is 0.5 kilometer again. So see, what is the time it takes? So the time he is going to take 0.5 kilometer. 0.5 divided by velocity in y direction. Velocity in y direction, what is the velocity in y direction? It is going to be VSR cos theta. It is going to be VSR cos theta. So this is going to be 0.5. What is the relative, what is the velocity of swimmer with respect to river? This is 3. And what is cos theta? So can we write cos theta? So we know cos theta, cos square theta plus sine square theta is equal to 1, right? So basically cos theta is going to be 1 minus sine square theta. So that is 1 minus 4 by 9 and root over. So this is going to be root over 5 by 3, isn't it? So cos theta we are putting here. So cos theta is root over 5 by 3. Yes or no? Please answer me. This is how you can get the cos theta. Sin theta you have. It's standard trigonometric process, right? We normally do it. Yeah. So root 5 by 3. So what is going to be the time? So it is going to be 3 cancelled out. So it will become 0.5 by root 5 of hour. Understood, beta? Understood? Yeah? Is it clear? And this is also the concept of minimum distance. So one point to be noted, like whenever they say this minimum distance thing, so see, don't remember this formula. I have seen teachers of schools normally, they teach this topic from this, like if minimum distance is to be covered of sine theta. So this is not like, is there anything very difficult in this? So they tell you this formula. So don't memorize this formula anyway. Like it is simple application of this concept only. Yes or no? Please answer me. Yes, sir. Okay. So we'll see a lot of these questions in the NEET. Let's see one. Okay. Let's quickly solve this. Please solve this. Please do it very simple. So when you are telling the angle, always be careful that they are asking you the angle from what reference. Okay? This is also important, that you take care of the reference from which they are asking you. Hmm. Very easy, na? Ansh, you please also try. Ansh, please Vida, try answering it. She say, see, basically when you are doing a question, try to be more patient. Okay, it doesn't mean that you take more time in a question, but like you try to be more patient, and this will happen. Like when you practice more often. See, this is the problem, and it is exactly, I don't consider this exactly as a problem. More silly mistakes you do before the examination, better you will be prepared for your examination. Are you getting my point? This is what I believe. Huh, Ansh, can you try answering this? So what it says? So it says the speed of a swimmer in still water is 20 meter per second. The speed of the river water is, so what is given? So this is your velocity of swimmer with respect to river, that is 20 meter per second. Okay. The speed of river with water is 10 meter per second. So speed of river water, that is this. So velocity of river with respect to ground is 10 meter per second. Okay, very well. Is flowing due east. So this is going in east. If he is standing on the south bank and wishes, so south bank. So this is your south bank, let's suppose, and crosses the river along the shortest path. So shortest path thing, right? So shortest path is, this is the shortest path, isn't it? This is the shortest path. So they are asking you what angle he should make with respect to the north. So with respect to the north, let's suppose the angle is theta. So we just have seen now how we can do. So see, if you don't want to remember the formula, see, you know the drift has to be zero. So in this case, the velocity, the net velocity, the velocity of swimmer with respect to the ground in x direction must be zero. So for that, VSR sine theta is equal to VR. Okay. Okay, so that is going to be sine theta. So what is this VR? It is 10 by 20. So this is 1 by 2. So sine theta being 1 by 2. Sine, so this is going to be sine theta. VR is 10, VSR is 20. VR is 10, VSR is 20. So basically it is 1 by 2. So from here theta is going to become 30 degree, and this is 30 degree towards the west from the north, isn't it? Right? So this is going to be the A option. Clear? Hai? Please answer me that. Right? Please answer me. Now, minimum distance thing is covered. Now, what if they ask you that what is the minimum time he requires to, one is the minimum distance, other is the minimum time concept. So, when they ask you the minimum time to cross the river, in that case, what you need to do? In the case when they ask you that what is the minimum time he requires to cover the cross the river, minimum time required to cross the river. So what it is going to be? So let's suppose this is your river. Let's suppose this is your river, and this is your point A. This is your point A. This is your point B. So he want to cross. So see, whatever it is. Let's suppose this is D. Okay, this is D. Now please tell me. Huh? Yeah. Sure, say exactly. Now please understand this. See, very very simple. So when he want to cross this river, basically he has to cover or she has to cover this d distance. That is the width of the river. Let's not call it d actually. Let's not call it d. Let's call it b. Okay. Okay. Or anything. Yeah. Let's call it d or anything. Okay. Now, please tell me that when he wants to cross the river, no matter in which direction he is traveling, he may be going this way, he may be going this way, this way, this way. Any way he is going, he has to cover this distance, isn't it? He has to cover this distance. So let's suppose that velocity of swimmer with respect to river, let it be in this direction for time being. Okay, and let's take the theta like this. Okay, so when he has to cover this distance, okay, the time that is going to be taken, the time is d upon, so the perpendicular component of it, so there is some velocity of the river. Now you have observed in each and every question that this has nothing to do with the vertical component of the velocity of swimmer with respect to ground. Does the velocity of river has anything to do with the velocity of swimmer in the perpendicular direction or in the y direction? No, sir. So it has no relevance in this case, no relevance. See, what is the velocity of the swimmer with respect to ground in j direction? So basically, it is the component of this in this direction. So what is going to be the component of it here? So this is going to be VSR cos theta, isn't it? VSR cos theta. Do you agree? This is the time in any case. So many students who like love to memorize the formulas, they can memorize this also. Again, I don't recommend it. Right? Don't fill your brain with all these formulas. When you know the concept, you can do like this. Okay. Memorizing is more difficult. Okay. Okay. This is what I feel. Rest it is up to you, obviously. Now please understand this. So see, we want to minimize the time, right? If we want to minimize it, okay, this has to be maximized because it is in the denominator. If this is to be minimized, this has to be maximized. Yes or no? If this is to be minimized, this has to be maximized. Agreed or not? Please answer me. Agreed or not? If the time is to be minimized, this is to be maximized. Now, what is the maximum value of cos theta? See, VSR is a given value. The velocity of swimmer with respect to river has a particular value. So for this to be maximized, cos theta must have the maximum value. And what is the maximum value of cos theta? Sir, it is 1. It is 1. Right? So basically cos theta is 1, that is theta is equal to 0 degree. Now what is the theta we have taken? We have taken theta from here. we have taken theta from here. So if you want to have the minimum time, the theta has to be 0 degree, right? Or you can say, so theta has to be 0 degree. That means that you are traveling basically like this. You are swimming like this. You have to swim like this. VSR. So when theta is equal to 0, theta is equal to 0, that means the direction of the velocity of swimmer with respect to the river must be like this. So you can also say that this is 90 degree from the direction of flow of the river. So basically when you want to cover the distance in minimum possible time, travel perpendicularly. Are you getting my point with the direction of the river? Okay, is it fine? Please answer me. Yes or no? Please answer me. Yeah? Is it okay or not? Please answer me. Please answer me. Clear? Everyone? Right. Any doubt in this? I don't think that we need to do any question of this. Right. So if a question is asked, will you be able to do this? Okay, so I can say now that relative velocity in 2D is also finished. Relative velocity in 2 dimension is done, completed. Can we say so? Right, so motion in a plane, we have only one topic that is left to be completed, and that is your circular motion, right? Other than that, all the topics are completed. Okay, okay. So you can solve the questions. We'll come up with the question solving sessions. So in the question solving sessions, we can obviously solve these questions, right? Okay, sounds good. Yeah. So now in the upcoming sessions, we have one more topic to be left in the motion in a plane, that is the circular motion. So very soon we'll be completing that also. Okay. Again, similar sort of concept is there. We have to use some vector, the kinematics what we have learned, and we are good. Okay. And some part of circular motion thing, uniform circular motion thing, we have already done in the vectors. Do you remember that? Right? I hope yes. So guys, the new students who are new to the session, who are watching this session, please do subscribe the channel. And with this, thank you very much. Have a good day and we'll see you in the next session.